Hi, I'm Dave Robinson, and welcome to another screencast where I'm going to be live streaming my experience in the SLICED competition. So the SLICED is a great machine learning competition. There should be a link in the show notes where I'm going to be competing against three other contestants to analyze a data set, and then here I go. I'm going to go up 7, I think we are. We're going to analyze the data set. I just got this data set about 5 minutes ago and I've been exploring it. It looks like it's going to be a really fun day. I'm going to be predicting whether a bank customer churned as based on a couple factors like their age, gender, education level, income category, number of relationships. It actually doesn't tell me what the data is about. So transactions. So I don't know what relationships and things like that mean. An activity I've done churn analysis before in my job. So I'm in various jobs. So I think I'm excited about, I'm pretty excited about applying it here. Credit limit, I was taking a quick look at these. They allowed us to take a look at it. I can't code until 9 p.m. Eastern, so it's about 6 more minutes. So I'm just going to be, I'm going to be just taking notes for now. And right now they've been allowing me to take notes where I can say, okay, the ID and response, the 3 categorical variables, gender, education level, income category. 2 of these, education level and income category, are kind of ordinal. Like we can actually see that education levels like college, probably something like college, graduate, high school, college. It's uneducated, high school, college, graduate, postgraduate, something like that. There's also unknown. And income category 2. So those are some we might want to parse some data out of. And to turn into an order, and maybe we'll get a better model out of that. Then we have things like total relationship, relationships, months inactive that are numeric, and they're not normal, but they're not. I don't need to log them or anything. Credit limit, I could log that if I'm looking at a linear scale, kind of a lot at the max, the minimum. I'm just taking a quick look at some of these before we start our coding. It'll be 5 minutes. Some thoughts on the strategy. Is when I do linear logging credit limits, maybe others. I don't know. Do I really want a linear model? Maybe I do. Maybe to understand, to get some interpretation out. But I'd probably just start with some scatter plots and stuff. Oh, so let me see. So one thing I'm going to note is create summarize attrition function early on. That's what I really like to do. Is I like to say I really like to say I have to create a verb that says, oh yeah, group by this and summarize, and that'll let me analyze some things in terms of by bucketed customer age, by gender. So let's actually note up some EDA. We're going to want to know relationship between age and attrition. So that's a summarize and a line plot. A lot of these are going to be line plots. Whenever they have scatter plots, when we have this outcome, education and income and attrition. Probably a bar plot. Income category. Total relationships. Attrition line plot. I'm not adding a lot by looking into these, and months inactive. So I'll actually say age, relationships, and well, actually let me see. I'm kind of thinking I'm just thinking of whether these can be done. Relationships and months inactive. Can be done as a line plot, and then the bucketed line plot, where I'm actually going to use cut, is going to do a relation between what is it, months inactive, credit card, so months inactive, total relationships. Sorry, no, I'm doing this wrong. Credit limit. So credit limit. Where's my utilization ratio? Oh, they're the rest of the columns. Wasn't looking at all of them. credit limit, total result revolving balance, age, total revolving balance, total amount changed, total amount, this is how much it changed from Q4 to Q1, so kind of like a trend. Total amount change. I really want a lot of line plots here where I'm going to say like, what's the relation between this? I can also use like, I can use, a density plot. Actually, let's do a density plot. For my large numeric ones, total transaction or total transaction. I'll just do of all numeric comparing attrition. And then it'll kind of tell us some of the places we can look. I'll use AUC of attrition versus all predictors. I want to try like, I'm just looking around, average utilization ratio maybe is log plus some small offset. A lot of things I can do, but just like, all these numerics, I'm kind of, I was excited to try like an extra boost on these. Attrition flag is going to need to be, attrition, change to churn, what is it? Churned. Yes, no, going to be a lot easier to work with. I know the word attrition is too long. I'll say churn. Yeah, this would be some good stuff. Yeah, so we're going to see some of these relationships. Then I want to dig into a little more some of these variables. Did I mention gender? Yeah, the gender. Is it? Oh. Let me see this. All right, here we go. And let's go. Tidyverse, library scales, library. What else do I use? No text in this one. I'm not gonna really use Uberate. I'm gonna use stacks. I might use that, and then theme set, theme light. And I always do parallel, registered parallel cores equals 4. Then let's read in our data. So we'll do read CSV, desktop, it's download, sliced. Here we go, and train, and I actually call this one dataset. And hold out. SO1, E8, look at me, I'm nervous today. I'm so excited. I'm so excited to be here with you, to be code and read all the, doing all this. And then we'll say split is initial split of dataset, train is training on split, and test is testing on split. And I neglected to do set C 2021 as my tradition. In fact, I also like to do train 5-fold. So train V fold CV5, and I do it all in the same plot. Okay, now we actually can take our training data and work with it a little bit. I'm actually going to start. I almost forgot. Mutate attrition. Churned is if else. Attrition flag. I don't want to keep writing that. Attrition flag is 1. Then yes, no. And run through there, and I'll select. Okay, and there we go. Then we do summarize churn, just because it's easier for me to write, and say tibble, summarize n is n. I always like this. I like this n churned. Sum churned is yes. PCT churned. I did something really similar for my last lap, so I like to apply here another train, summarize churn, There's an approach I like in here where I say, I'll do this again from as I said last time, say low is n churned plus 0.5 n minus n churned plus 0.5. High is q beta 0.975 n churned plus 0.5 n minus n churned plus 0.5. That's the stuff. And now I've got my low and high. Why am I doing this? Because now I can group by gender. And now I've got my stats. I can start seeing things like, okay, the churn rates actually do differ. Where I actually can say PCP churned, gender, geome error bar H, X min is low, X max is high. I have a couple of these numeric ones, and I don't like how tall that is. Height equals 0.2. I don't know, color equals red? Sure, let's go with it. And let's do percentage churn, churned, and yeah, let's kind of go from here. And what I might do is I might say categorical function x, the data, and then x, and actually I'll x in category. And there's a great trick here, tidy del, where I can say, is it double hug? I believe it is, yes. And then I say all the rest stays the same. Except I neglected to do, so piece tier insurance category, oh, I forgot to do category gender. And really I can do category and then dot, dot, dot. Why am I doing this way? Because now I can actually, you'll see I'll be able to do other summaries. And, that doesn't look good until I have scale x continuous labels equals percent. See, I want to get a quick machine of being able to say, okay, I've got gender, now I've got education, and this one is not going to look as good because it's going to be alphabetical, and I might want to start by sorting it, but you know, the funny thing is, like, so I can do mutate, I'm remembering myself quickly, I think it's this, category is FCT reorder by PCT churn. I think this is right. Let's find out. Yeah, so we got like college under. You know, what's funny is like it's not perfectly ordered, and it's telling me it's like you know, it's like doctorate and postgraduate, highest churn rate. College, undereducated, all lower, but at college, in fact, the highest churn rate. Now let's also look at age. So there's a few ways we can look at. Actually, let's do income level. Let's throw in gender and try fill equals gender. But to do this, I'm gonna need position equals position dodge. Here, and in, yeah, the problem is the, I see my color red really got in the way here. This is not actually a perfect graph, because I'm going to want to, here we go, where's my, right, fill and color equals gender. And in here, I'm going to need, in the error bar H, I'm going to need position equals position dot. I don't know if this is going to work, and it's okay for me if it doesn't. Position, it is, but it's not wide enough. Width equals 0.5. I'm not sure what the exact width. Width equals 1. And also, I do need it to be, I changed my mind on the color. I'm going to need this to be, let me see, I'm going to need a group. There we go. Okay, so yeah, so is there an interaction term? Don't think there's an interaction term. All right, but let's keep grooving. So the income category is let's see. Let's reorder that appropriately. So I'm going to try. Let's actually do that. Where am I going to do that? Yeah, I'm going to do that up here. No, here's what I'll do. I'll do FCT reorder. It's going to reorder it in the innards of it, in the innards of plot categorical. So if whole tibble category, if it's a factor, then we say, if not a factor, then tibble. I really just want to have this general function. Even if I don't use it a lot, it's just nice. So now I'll say mutate income category is FCP reorder. Here's something fun. Income category by, I'm going to reorder it by parse number of income category, and then I think it's good. Income. Did I spell one of them wrong? Object income category not found. Yeah, I've got my income category. Here we go. Tibble is this. Oh, here it is. Small bug. See, here's what we did, is we put I tried reordering them. Did it work? Pull income category. Yeah, it does have them in an order, but I actually also need to put the less than is FCP relevel income category less than 40K. I need to put that as its own category, and the yeah, that's gonna be better. Here you go. It's maybe there's a trend. It's pretty hard to sit. It's kind of like a, there's like a, what if I chord flip it? Yeah, I like this one more. That's happened sometimes. And yeah, let's do a couple more things to say. And what if instead of a bar plot, no, I'm going to keep it as a bar plot because it's categorical, even though kind of like the line plot. Income category, and by education category. There we don't actually have a better trick than count education level and do FCP re-level education category and give it just a vector where we say unknown, uneducated, college, nope, high school. Create this up here. I'm just sorting them intuitively in terms of high school, most efficient least, college, high school, college, graduate, post. I actually don't know if graduate or graduate, doctorate. I don't know if postgraduate is more than doctorate or not. Because I guess postgrad, it's more. Like non-medical PhD, post-PhD, I think that's right. But I don't know. We'll see. And the yeah, we say how does turn risk if everybody so then I can and I want to do education levels. I want to do this early on, so I'm actually going to do it process data. I'm going to do this, oops, and I'm going to do income category. Why am I doing up here? So I can do it both to both training and the test sets at the same time. Anything I do to train is not going to keep processing forward, but I need this processing to happen to everybody. I could do it in recipes, but like if I do it up here, yeah. And I did something wrong. Let's see what I did wrong. Education category is actually education level. Yeah, looking pretty good. These are NAs are unknown. That's going to work out, I think. So the so here we go. And now if I do plot categorical, yeah, I'm going to do. I guess unknown at the top is not so bad, but yeah, this is kind of like you see it drops and then it goes. It's like in the middle has the lowest churn risk, and you kind of actually see something a little bit similar with income category. You know, that actually makes me think I'm going to cohort flip. And let's put, you know, unknown is not actually at the bottom level, but let's put it at the bottom. So we say, and let's cohort flip this one too. So, I'm sorry, this income one too. How does churn risk differ by, let's see. So here's income category. Oh, where are my labels? Oh, right, the labels get flipped too. That's fun. Haha. Usually I have a, yep. Haha. Here we go. Income category, we just go on the Y, X. No, this is still right. There we go. Yeah, that's, well, these are both same thing. I really wanted to get some of these graphs down, like unknown uneducated high school, college grad, not a lot, maybe a little higher among doctorates. Hard to say, but that's going to be for the model to decide. So the yeah, that's actually those are categories. Yeah, we have one more that I want to see, which was age. I did want to see group by age is cut age into, let's say, what did we say age was? Yeah, like, I don't know, less than 40. So like 20 to 40 to 50 to 60 to 70. Does that miss any? Customer age? Plot categorical of customer age. Yeah, so we see like, no, not a ton. And let's actually look at all the let's look at all the numerics. And this is a nice trick. What I can do is say train let's do select negative. I select just you know, it's actually everything except for those few. So I'll say select churned. No, actually churned and customer age and total relationship count through. Actually, I can do it through churned, and I'm in good shape. Gather metric value, everything but churned. And facet wrap by metric. Something feels actually odd about these. Like, it's not crazy to be large, but I didn't expect them to be quite that large. Or maybe something more. Oh, of course. I need scales equals free in the facet. And this is like just a nice graph where I can say, yeah, like some of them don't need to be logged, some of them do. And let me see. Yeah, here's what I'm going to try. I'm going to try. Look at total revolving balance. Look at that difference. Look at credit. Some of them, like age, don't really matter. Total transaction count, total transaction amount. Some of them really do. See, a log is in alpha equals 0.5 and title. This just gives us a place to start when we're building a model. And, you know, there's actually an alternative here where I could actually do all this. I'm trying to make it cleaner if else. There's a string to title match. Nope, churned. String to title churned. And gathered. Gather, and I'm going to try one other approach. We're going to say gathered rank is rank of value grouped by metric. That'll mean they would be uniform. Oh, and drop the log scale. Sorry about that. Percent. I think it's called percent rank. And this is rank 1 sec. Yeah, we can actually just get a sense of what is what is like the difference between them. And between 0 and 1, it's a little wacky to do it on a density plot, but some things we can kind of like just see differ objects on a percentile scale. Okay, so let's actually start building building models. So I really like the I really actually like this data set. So the so here's what we'll do. Let's do an XGBoost because we have a lot of numeric stuff. So XGBoost on ones that are clearly predictive or low cardinality. So what I'll do is say recipe of so XGRec recipe of churned explained by gender plus average utilization ratio. I'm going to go back to the log scale. I liked it a little bit more for being able to see this. A little more intuitive. No, that wasn't not such a big change. Oh, total transaction. And I'll do, you know, yeah, let's do a few. And train equals data is train. Step dummy categorical. All nominal predictors. Do I have any missing data? Do I have any missing data? Nope. That's pretty cool, actually. Wow. Yeah, so I'm going to start just months inactive. Yeah, I can actually see some relationship of credit limit months inactive 12 months. What is that? Is that right? No, what does it say? Months inactive 12 mon. All right, and then I'll do, that's actually not a lot of cleaning. And then, oh, I neglected to do a couple things. We are looking for metric set mean log loss. And I need control grid, save workflow true. I always like save pred true, and extract equals extract model. I like to grab these things. And yeah, and then I'll do here's extra rec, and now I can actually create the workflow in one step by doing, because this is because I'm using the if you're following along at home, you'll need to boost tree classification trees equals seek 100 to 1,000. It's much more condensed by 200 to 1,000 by 50. I've learned recently that learn rate is 0.02, maybe trains a little faster, and the and I may not need 1,000. I may need 600. And M try there's 1, 2, 3, 4, 5, 6, 7, 8, 8. So I'm going to try like I don't know 3, 5, 7. Do a little more than this. XG tune is XG workflow, tune grid, train 5-fold, metrics equals mset, control equals control. I always do this thing. Have you noticed that I'm always doing this? I need to do tune, mtry is tune, alpha rate. This one I can set. But here's where I do crossing. Oh, I do not need a learn rate because I'm not training with it. There we go, training our first model. Well, I haven't even paid attention to things like how big are these data sets. You know, I'm going to open up that second project where I'm going to do EDA. I'm not sure. Oh, yep, and here we go. So, yeah, I don't need start out so early. 7's a little worse. 3 is kind of beating them. It's going to stay like 3 and 5. Oh, wow. Oops. I meant to do 200. Yeah, so we're already at a good starting place. 20, because I can do as many of there as I want. 3, 4, 5. All right, so 0.111 is like the best we've been able to do yet. Trying smaller ones and a little more precisely. I'm going to try tree depth pretty soon. I'm going to try adding in more things. I'm going to be doing an importance plot. Yeah, so look at that. It's like 3 is kind of the best, and maybe others. And that makes me want to also try out 2, and also try out also try different learn rates. Yeah, just worth experimenting a little bit with this. And 5 is clearly worse. So I'm going to drop 5 out of the equation. This is only on a subset again of the predictors, like most of them are numeric except for gender. And let me open up my second one. And get out the same approach into early data, except without any parallelization. So I don't want to use the cores I'm already using over here. That one I'll do EDA, and yeah, this one I doubled the number. I'm doing like 0.01 and 0.02 for my learn rate. I'm trying a few things. So like about 0.11 for 0.11. Yeah, I'll need more trees at 0.01, so I just don't love that. I'm gonna stick around 0.02 for now. 0.02, about 2. Wow, 2 is doing like just well, and it kind of like, yeah, I'm gonna try, but I'm gonna increase this a little bit. And let's try all numeric and turn categorical into ordinal. So here's what I'm going to do. I'm going to say by dot set ID new role equals ID. Wow. Trial numeric, and let's say CV is, what was the binary log loss 0.11. CV log loss is about 0.11, and let's do it. Oh, what am I doing? I already did that. What I want to do is say train and step dummy and step mutate income category is as integer category, except I want unknown I want unknown to be NA. As And I need to move this 2 steps later. I want to bake this to make sure I'm in good shape. Extract, prep juice lets me, hey look, I have some missing data. And I like that. That missing data makes me feel good because I've got numbers there. And correlation count. Yeah, see, everything's numeric now except for churned and male, female. Okay, so everything is numeric. And yeah, all right. And then I do need one extra step where I say step impute mean all numeric predictors. And yeah, I'm going to try one more of these. Yeah. Let's try a whole bunch of levels. So, yes, everyone. Shouldn't have been that commenting that well. Yeah, it doesn't matter. All right, so we're 34 minutes in. We're training a model that's going to be like, it's going to be on all the data. So trained, yeah, let's see. Trained a model on all the data with income, with income and education turned into ordinal variables and unknown imputed using imputed to the mean. I'm not sure. That might not be perfect. Maybe unknown is more similar to one side or the other. That's kind of plausible looking at it. I should revisit that choice. I don't know that they're going to turn out to be that important. But yeah, that's my factor to ordinal situation. And yeah, I love that I can do all these like tree points and try different learning rates. It's very powerful in tidy models. So CV log loss on did around 7 predictors, 1.11. All right, let's also set up our code for so XG fit. Let's set up the code for fitting the full model. Yeah, one thing I can see here is 2 is not going to be good when we have that many predictors. 6 seems to be the best, and it's leveling. Oh wow, we can easily beat the others, the ones we already had. So the with all predictors. In the rest of predictors, around let's see, 0.087. Let's try that on training, on testing. So the what I do is I do XG fit, XG workflow, finalize workflow to select best XG tune, which, by the way, will be 6. Yeah, we can see it's like leveling out around there. You know, let me. Yeah, I'll start with that, and yeah, then we'll try XG fit, fit on the full train data. Oh, oops. And augment on the test, and log loss, mean log loss of the truth of oh, it's estimate the truth. Nope, it's not pred class that I want. Well, I need to remember dot pred yes. Oh yeah, that's a good. Dot pred yes, and churned. Churned is a character? How did that happen? Oh, yeah, look at that. Look at it go. That did happen, didn't it? I wonder if that makes a difference anywhere else. Uh-huh. Always forget that order. I'm doing it backwards. Ha. There we go. 847. On test set, 0.0847. Cool. So the and let's look at the importance for a sec. I learned recently a trick thanks to someone. Sorry, I forgot their name on extract fit parsnip. That's cool. And then XG boost, XGB importance. See, this is the trouble is the fit doesn't get it all. The fit still, I'm still sort of learning my way around this. I want the actual fit. Oh, the engine specific fit. Okay, I think that's right. There we go. Okay, so it's like, yeah, I think we actually saw these earlier: transaction amount, transaction count, revolving balance. Those matter a lot, and things like income category and education. You know, we turned them into ID. I'm so sorry. Step remove ID. I never figured out quite how the roles work. I'm sure somebody can point it out later. But I mean, it's not important, of course, or hopefully not. But I included it anyway. Yeah. So one thing is the categoricals ended up or the setup categories ended up like not mattering very much. I could leave them in, but like I could also narrow them down and possibly improve it. I would probably cut the line here with like months inactive, 12 months, and just skip the categorical ones. And yeah, age still matters, and a lot of these ones like transaction amount, transaction count still do matter. And I'm gonna be doing some scatter plots on those in a minute. So I'm gonna add some EDA to dos. So I'm gonna here we go. F7 EDA. Yeah, it's still training. You know, I didn't have to start with 2. I could have narrowed this set down a little. You know what? I am gonna narrow it down because I saw the best was around like 6. So I'm actually gonna do 3, 4, 5, 6, 7. No, 4, 5, 6, 7, 8. I go a little bit farther. It'll take a while, but yeah, it'll be worth. It might presumably be worth it. But now at least I've gotten rid of ID, and I might get rid of the. I might get rid of the. You know, I might get rid of the other ones too. Yeah, let me get rid of the ones that are the absolute bottom. All right. It doesn't mean you know, I'm not going to drop gender because it's a smidgen more important. But yeah, I definitely am removing the ID. Okay, and let's look at some relationships. So like, for instance, I'm going to write like total transaction amount, total transaction count. How do those? I mean, those are going to be extremely correlated. but it seems like those are the two most important. So let's spend a minute looking at total transaction count, total trans amount. Look at these levels and stuff. That's kind of interesting. Or is it? I wonder. Yeah, and let's do color equals. Still going, still going. Yeah, and I'll do alpha. Look at that. It kind of does look like there's an interaction between them. So total. I assume that's dollars. I'm going to quickly check. Total transaction amount. Well, this says value, but I am going to assume that it's dollars, and say labels equals dollar format. Yeah, and like, yeah, I really want to ordering, try make it a little bit more transparent, and let's do geom smooth. Be a little bit slow. It's not too slow. Yeah, it's kind of like, yeah, look at this. Total transaction amount, like the people that churn have at higher transaction counts. There's a ratio of average transaction amount. Low transaction count. So let's actually do this as transaction count over average. Do they already have average? If so, I'm doing this work for nothing, but I don't think they did. So look, I'm doing like average transaction amount. And yeah, it's like this is kind of more straightforwardly, for most of it, it's a little bit higher. And I think like instead of total transaction amount, I might use average, or I could use both of them and see how that works. Yeah, so what did I get? 847. It was like slightly. Well, I dropped out ID, but like it's pretty similar. Oh, and let's look at these. 4. Oh wow, yeah. So when I dropped those out, 4 became the best. So I might want to try 3. 7. 7's the worst. Then 3 through 6. Learn rate 0.015. It's kind of experimenting with this. Then I was going to throw it back in. Yeah, I might want to add average transaction amount. So the that means changing multiple things at once, but average transaction amount, average utilization rate, total amount change, total revolves. It's back to the 12 months total. Yeah, I'm gonna. Yeah. And let's see this, total relationships. That's cool how much the relationships matter, though I have yet to do this. And all right. labs. Here we go. 3 is on higher learning rate, doing better so far. Okay, and what was that best? 853. That's pretty good. I'm going to throw in the one we just came up with. Average transactions is transaction amount is this. Eight, 5, 3. I gotta keep only the one learning rate for now, and her average transaction amount. And let me quickly check on total transaction amount. Was it ever NA? No, it was. I want to make sure I'm in total. Oh yeah, we can see it's always at least 10. Okay, then then here we go. Let's see if we can get any lower than 0.0853. So it's 7 or 853. The one thing is, I'm some creative visualization I'm going to do today. I don't see any I mean, I've done some like a little creativity, like some of those faceted ones, but the average. You can actually try a different one. You know, it's funny that small transactions that are lower, people that churned have lower transaction counts, but then higher average transaction amounts and high transaction counts. Like, yeah, oh, okay. At this count, higher transaction amounts are more. Churners can have higher transaction amounts. It's so weird. I can actually explore this a different way and say train group by relation by total transaction count is cut total transaction count 0 to 30, 50 to 100 to infinity. And basically the same one I had before. Notice most of them are 50 to 100, so oops. And the get back to that in a second. Yeah, 3 predictors. That's the minimum. Whenever the minimum does best, I always wonder is should I bring it down a notch? The 0.04 yeah. All right. Let's stick with that. On mtry 3 780 trees. Learn rate is 0.02. Let's do our first one by the hour. Let's do our first one, yeah, at the hour when we see, all right. It's similar to the model we had before, maybe a tiny bit worse. But I'm all right with that. It's like I think the other one's 0.047, whatever. Yeah, then all right, XG fit full is going to be the same thing, but fit on the full data set. Everything except education here added. Just wanted to note what attempt. I just want to check. It's prediction yes that we supposed to have. I imagine so. Is the probability of attrition flag? Yeah, it absolutely is. But I'll make sure of that in a sec. Okay. Fit full augment. Yeah. Oh, shoot, I need to give it the right name. Attrition flag. Let me take a quick look before I submit to make sure I'm accurate about what's in the model. Actually do it on XG fit. I'm not going to do it on XG fit full. Extract, parse. Got average transaction amount and yeah, no ID, no anything else. So, yep. Put it in one line, making sure I put the right version. Oh. All right, that feels too good. Yeah, it feels way too low compared to the other ones I was looking at, but I guess it's very few observations. Yeah, yep, definitely getting crushed by a few people up there. We don't pay too much attention to it. But yeah, how much data is in the holdout anyway? 3, yeah, so that'll be times 0.01. All right, then the about 30 observations. Yeah, it's not going to be tons of it, but yeah, it's at the very least I'm not like getting it backwards or anything. The meaning backwards. That's what I matter. All right, so let's do plan. Let's see. Plan for second hour, more tuning on learn rate and max step, and then the trains. Cool. I'm gonna get some water. I'll see you in like 3 or 4 minutes. You know, I'll just. Don't tell me anything. She said that down in this court, just don't say anything. Also, if you hear that down this door. All right, let's go back in. So here I'm just seeing like, got these 12 features. 3 is the best hold. Yeah, let's see. Just make sure we get this right. Oh, I just did this. Oh wait. Oh. Biggest randomness? Or did I change the work phone in the meantime? Yeah, randomness. All right. Yeah, you know, it's really hard to tell with the randomness. Okay, so the all right. So what I'm gonna do is start by bringing it down. 5 and 6 seem to do really poorly, though. Maybe that'll. Yeah, they're doing poorly for now. 0.01, 6. 0.024. Yeah, I'm messing around like a little with like. No, I'm gonna start just here. And yeah, mess around with the learn rate a little. Well, we really do feel like the key is 2, 3, maybe 4. Yeah. Okay. So yeah, what I'm gonna do is low transaction count. And you know what? I like this ribbon plot. I should turn it into a function interval x. All right, the summarized churn. Oh yeah. See, like, look at that. Isn't that look great? I think it looks pretty good. And the of this is good, and whoop. Oh, I already have this. I've forgotten this trick. And group equals 1. And I need that to happen on this one too. I'm not going to get there. All right, so total transaction count, bucketed. 30, yeah, notice most of them are 30, 40, 50, 60, which is a little odd now that I think about it. Yeah, so it's like, oh wow, look at that relationship. That's pretty cool. And let's also group by total average. Let's group by average transaction amount is cut. What is the distribution of average transaction amount? Remind myself what I'm up to while I go back to this plot. Yeah, the I think it does best. 102. See, this is so close, so close. I might increase by to like 2,000, but wow, these are close. They're not like, yeah, they're like pretty damn comparable, and we're all in that kind of that same zone. So the yeah, what am I gonna? Just thinking for a minute on what to do with this. The I am going to increase the number because I have more time now, but I really want to. I want to try some tree depth things. Tree depth is I think it's around 8 or something like that. So it's like 5, 7, 9. Well, I'm doing very few depths though, so I don't know, 4, 6, 8. And 2 is sort of worse. They're all pretty good. But I'll try this. All right. Give this a whirl, see how we do. And yeah, so this is like the role of transaction. But notice many also really likely to churn. Really interesting. And yeah, I'm gonna keep this. But then I'm gonna say, oh yeah. I was gonna do genome histogram. So I can really, whenever you see something like this, you want to dichotom, you can trichotomize it. So like Here's what I'm going to do. I'm going to show 50, 110, 130, 130. Why? Why? So I can do this. I can say, this. Oh man, this keeps running faster than I expect. Tree depth. We get a tiny benefit out of this, best around 6. Well, I don't know, with 4 and maybe more learning, I'm going to increase this a little bit. Change this to 5, 6, and 8 is just like overfits real fast. 8 overfits fast. 7. I'm going to try that out while I'm going. And, all right, so what I'm going to do is say x-intercept is 50, 110, 130. Nope. Oh, whoops. I don't like that 110. I like 100. All right. Yeah, the reason I want that division is I wanted to cut it. So I'd say like cut 50. It's still running good. So I'd say cut 50, 100, 130, 125. 130, I said. And then infinity. And group equals this, color equals this. Too many break points because the 100, 130 is too many. Yeah, like, I mean, this is just not, yeah, this is still too many. So I'm going to try. Haha. Yeah, look at that. That's kind of like an interaction term there. You can see like the, it's kind of an interesting plot. Yeah, what I'm going to do is I'm going to change this to an if-else. Amount is greater than or equal to 50. All right. Yeah, there we go. Greater than 50, less than 50. Yeah, this is So what this says is that if you have a moderate number of transactions, ideal customer segments. Low number of so let me jump back to that in a second. Oh, this got a lot better. Oh, how did that get so much better? Oh, I see how it got. Okay, it got a lot better by what is the optimum? Is it around 6 or what is? No, it's learning panel 2, tree depth 6. So for, yeah, I thought I already tried that. I'm worried this is just me getting lucky on one. Yeah, this could absolutely be luck. So I'm going to do a couple things. I'm going to try set seed 2021. I'm going to reduce the roll of luck. No, I'm not going to do that. Yeah, I am, actually. 12. Oh, 07, 13. Train tenfold is train. Okay. Because, I'm just like, I'm just waiting on it. And, While I'm at it, though, I'm gonna expand out my set a little bit. Tree depth. Seeing like 6 was good. Try it out. It's gonna be slow. All right, but yeah, customer segments greater than. So let's see. 30 to 50 transactions, average greater than 50, likely to churn. 30 to, let me see, 50, so 60. Uh, 30 to less than 50. I had to keep this simple, which means we're dropping out, we're ignoring this section, but that is less than 50 transactions. Segment. Still going. For transactions, Oh, whoops. Red. I got these backwards. Look at that. Because, yeah, I want the, cool. Oh, that's going slow. Okay, so that was our, to summarize in terms of our learnings or an average transaction amount. So let me see. Ooh, whoa, this is just going and going. I guess it's got a lot of trees. It's got a lot of trees too. Let's see. Transaction amount is roughly bimodal. Product. Oof, this is slowing down. Something about this. It's going slow. Make sure I have everything. My model is anyway 2 times 4 times 16. That is tenfold. Oh yeah, that's gonna be slow. Oh well. The yeah, I probably should skip the tenfold cross validation, but you know, I want to be accurate. All right, customer segments. Let's go back to this. The low Hi, I should be back, I think, on YouTube. Let me see. Let me make sure I'm back. Uh, Great. Okay, looks like I'm back. I just want to make sure that. All right, and now I can jump back in. So here we go. Look at them all saved. I'm not going to do that tidy models. Like I'm not going to do a tenfold validation again. That took way too long. Way too long. I might need to reduce down the rest of them too. Just like, wow, that was a lot going on. All right. And no. And fivefold. I only have 4 cores, right? Yeah, okay. Fivefold and too many things going. I can try this on fivefold. Okay, and yeah, let's get back to my EDA code. Thanks for your patience if you stuck around. Train fivefold, do some churn. Still churn, yep. All right, total transaction amount. I don't like this one, but I'll keep it. Average. All right, return. We saw that average transaction amount is bimodal. Oops. That the yep, the total transaction count was like greater than 50, less than 50, and the yeah, and here's my dividing into segments based on churn risk. We might go back to the same graph on some other things, but what I really that means I'd like to find out what the other most important features were, but I don't actually have that graph handy. But I can go back to that rank one that that one that was faceted by metric. And say next one, we just look at this. All right, transaction count, total revolving balance, utilization ratio maybe has a little importance. I'm actually gonna take this gathered and I'm gonna ask about the. Wait till I get this, but let me do it anyway. What I'm gonna do is say gathered, group by metric, summarize AUC is ROC AUC of VEC of churned by value, and I always get it. It's gonna be churned value. Well, this XG tuning, it really is taking its time. And yeah, let's make this graph while we have it. We'll do metric is FCP reorder, metric by AUC, and do yeah, the geom V line out to Y is 2, X intersect is 0.5. So like age is not very important, but total transaction amount, count is important. So here's what I'm going to do. I'm going to add 1. I'm going to add mutate total average trans amount is total trans amount, total trans count. I'm going to throw that into the gather. Can you believe it? How many did I even do? I should have done two learn rates. That was indulgent. That's all right. So, where's average transaction? Oh, average transaction amount is not predictive on a pure linear scale. Average amount. So that's why I want to wait till I have an actual tune. There. Oh, all the models failed. For real? Haha. Okay, let's see what I did wrong. We're going to try is, look, here's one thing I'm going to try. I'm going to do xgrep prep juice. That at least didn't fail. Oh, metrics, mset. Let's see, all the models failed. So the notes column. Oh, cores did not deliver results. Signs up with my parallel processing. Let me try this with a smaller number. All right, that works. What was my best model again? I said that somewhere. mtry3, 780 trees, learn rate 0.02. 780 trees, I'm going to give it a little space. Three. Just experimenting around here, trying some different yeah, so I'm experimenting a little more cautiously. I don't want everything to crash again. But once I do that, I'm going to try out some of this model. In the meantime, yeah, the oh, I need to, yeah, I do need to get some model. What I do, I just doubled the amount of time it's going to take to run, and plus it's a little longer in the number of trees. Yeah, I'll give it a sec. I'll give it a minute. Okay, so to do is All right, the learn rate, let's see, yeah. Lower learn rate, it does better. All right, so the, and the best 0.084, but I think I saw better than that, but it could have been randomness. So 0.084, and I do need to start at 200 trees is too many. It's making it harder to tell where things go well. Let me see. Oh, but I do need to create this this graph before I do anything else. This importance graph. Okay, so the and transaction. It's interesting. Transaction amount is still more important than average transaction amount. Huh. Oh, the these two just work well together. Total revolving balance and yeah, some of the other ones we want to look at. Anytime I'm going to try this other. All right. So total other important ones to try. Yeah. Total balance, total revolving balance. All right, so the total revolving balance, total change Q4 to Q1. All right, yes, let's look at a few of those. So, and revolving balance, what is it related to most? Total amount, no, total count change, total amount change. And if I look at the, here we go. Oh. Where's my data? There's 1 second. Yep, the revolving credit, what's the total revolving balance doesn't answer. Yeah, I'm actually looking that up. Oh, okay. Yeah, like waiting till later. All right. So the so let's see. Total revolving, where was I? Oh, there it is. Okay, a little bit better. And the best was at 1,000. Look at this. Treat up 5. It kind of was still 0.02. Kind of still learning, but I still, I like it. Treat up 5 and this point, yeah. See, treat up 5 just was still learning at that rate. What if I removed the 7 and let it go to 1,200? And I decided that 0.018 is too low. Low, yeah, okay. So that one was 0.0841. Trying one more model, but in the meantime, yeah. So if I say total revolving balance and train, and let's look at total revolving balance. All right, starts at 0. So what that means is that if I want to look at the rates, I'm going to do group by balance bucket is cut of total revolving balance into 0, 1, 1,000, 2,000. It kind of locks out at 2,500. 0 to, let me see, where is that 0? Oh, yeah. Uh, 2499 and infinity. 2499 to 100. Yeah, they like, there's a bunch of little over 2,500. And oh, all right, here we go. The you know, I tried this and it's like a little bit worse than the last version. That could all be random luck. Seeing like really like 6 at this lower value, 5 at this higher value. It's hard to say. I still like learning rate 0.02. Yeah, I'm gonna stay just with learning rate 0.02, and I'm gonna go back to 3 and no, I'm gonna do 3, and I'm gonna give it one more shot at tenfold. Five or 6. Oops. All right, and yeah. So, I'm going to need a couple labels. There we go. And let's also bucket that by the, the transaction count. I really like that transaction bucket we were looking at. Let's bring it back in. And, no interaction term. Let's take a quick look at this. Yeah, it's like tree depth 6, 800. See, it's still not as good as those earlier variations. Where was that variation I liked? I liked 6.019, 840, but there's so much randomness here. But yeah, I'm just going to go with the best version, which, yeah, I'm going to go with the best version here. I think that's better than the, wait, what was it on? Yeah, it was a little better than it was on holdout. And yeah, let's remind ourselves what's in here. Nothing I don't want in there. Right, and have 2. Try is 3. Try is 3. Can 40 trees. Limit is 0.02. Tree depth is 5. And all right, actually, we fit it on the full data set of, let me show myself the full ones we do. It's the 7K. Uh-huh. Wasn't improving the best score. You know, I still like it more than the other score, because the yeah, I think I still like it more because it did have was slightly better in the test, and I have a lot more data locally. So I am going to choose that one. Yeah, even though it's like worse on there, and I'm also going to like, yeah. So what I'm going to try remove gender. Five, 6, and deciding like how else do I try adding and removing? Because I'm pretty close to. I feel like I'm pretty close to. I don't think I'm. I could easily be missing some like important one, but no oh yeah, interaction term. Not really interaction term, but total transactions. Let's try average transactions. One sec. Average transaction. How about that utilization? The utilization feels like it's related to the yeah, it feels like it's related, and I can say like what I want. There's a spike close 0 and 0.5, so let's make those the buckets. We'll say average utilization. Oh, it's still training? No, it's done. 0.857, still not doing better. So I removed gender, and did it get any better? Be sloppy and do it over again. No, it did not get. It definitely didn't get better by removing gender. Maybe it would if I move some of the others, but I'm not going to do that. And still seeing, yeah, I'm thinking through some of the things I can still mess with. So I don't have a lot of time left to play around. Oh, too many, yep, learn rate, tune, learn rate, tree depth, tune, oh yeah. Average utilization ratio, oh yeah, so here we go, average utilization. All right, and 0 to, here we go. So yeah, here's the story we can see on this, the scatter plot. Utilization. Average utilization. I think there's actually like a relationship between these two, where we can say average utilization ratio and balance, total revolving balance are clearly related. Yeah, look at that. They're cleanly like this. All right, I'm thinking of a few ways I can do this. Geom point color equals churn. That's cool. Everywhere below a certain revolving balance was churned, but I can do and yeah, that spike at 0 has a lot going on there. There's an interesting relationship. I can acid wrap by churned. Well, it's interesting relationship. And let me add a little bit of jitter to say height equals 0.02, width 0.02. Yeah, while this finishes training, I just make sure that I have, I've selected like 5. Yeah. Oh, that's too bad. Let me try it on 5. Try it on tenfold and do only one tree depth and only one rate. Sure. I'll try one more model. Okay, but the yeah. So one that's important is yeah. So let's look at this one more time. The utilization ratio. Point. You got to block down at 0 is kind of an important thing. And there is kind of a relationship here in terms of the total evolving balance of a particular region always churning. That's a little bit interesting. But yeah, but that's like kind of figured. Okay, let's take one more look through all the things there's fit and best was 5. This is really similar to the last one I had, like really similar. What would it have if I did, it was on tenfold? Yeah, it was. What would happen at 0.018? What would it say? Let's find out. But yeah, let's actually go through all the things that we learned in our EDA. So so first we tried doing we tried looking at like by gender, gender and education. Didn't see much there. Looked at it by education and saw like, okay, there's kind of like maybe a dip at college, but not a very strong one. A bit of a stronger dip on income that could pop up in other areas too. We realized then that and I use not a really strong effect of age. So then we took a look at all the numeric ones, and we said, note. You know, I really like attempt 2, so I'm probably just going to stick with it. But the yep, I like it. And yeah, what we did is we looked at how these predictors differ, give us some senses, and then we really looked at some relationships. Here's my favorite section, where we then looked at the importance of where we said two types of spenders. I think is that right? And the average transaction amount is roughly bimodal. I guess maybe people that only save their, do a few transactions that are all large, much more likely to churn. This is my favorite graph we made, and I like that we were able to turn it into this, this like segmentation kind of thing. I think it's the kind of thing that could be understandable. I'm going to make one quick labels equals %. Oh yeah. All right, so really important, go over to the Twitch. If you're still watching this on YouTube, please go over to the Twitch account. And the just go over to the Twitch account and please make sure to vote for me. So that's there's a link in the YouTube. It's on Nick Wan's Twitch account. So I'm going to end the screencast here. Excited to see you over there. Yeah, I hope you had fun. I certainly did.